Good morning, all. So, today we are going to start a new topic, that is section of solid. So, section of solid means it is nothing but any object or a solid will be cut by some imaginary plane, cutting plane, in order to understand the internal details of the objects. There are certain internal details such as the holes were there, threaded holes were there, intricate shapes were provided. So all those things we can able to get it from the section of solid. So sectioning means action of cutting is called sectioning. The section plane is a plane used for cutting, we call as a section plane. So why we are doing this? In order to get the hidden or internal parts of an object. There are two types of cutting planes. One is auxiliary inclined plane, second one is auxiliary vertical plane. So we define auxiliary inclined plane as a plane which is inclined to HP and perpendicular to VP. An auxiliary vertical plane, a plane will be inclined to VP and perpendicular to HP. So these two types of planes will. Auxiliary inclined plane is a reference plane which is perpendicular to the vertical plane and having inclination to the horizontal plane. You can see clearly in the diagram, it is exactly 90 degree to the vertical plane and having inclination to the horizontal plane. So this is our auxiliary inclined plane. Auxiliary vertical plane is a reference plane which is 90 degree to the horizontal plane and having inclination to the vertical plane. That is, it is exactly perpendicular to the horizontal plane and having inclination to the vertical plane. So this is what our auxiliary vertical plane. You can see the section plane will be represented by like a chain line. Okay, you can see there is a long line and then subsequently followed by two short lines. The same way it is continued, and at the end you can see there are two thick lines written, and there are two arrow marks exactly perpendicular to the thick line shown and written with the capital S. So this is how we represent a sectional plane. So wherever we write the cut plane, so this is the symbol we should mention. Section plane. Okay, section plane means what? Section plane, it is nothing but a imaginary plane, okay, using which we are going to cut the section of the solids in order to know the interior details of it. Okay, so sometimes what happens in the solid, there are intricate holes were there, intricate shapes were there which is not visible. Okay, so in those cases we are going to cut that particular solid in order to see the particular section. So how we define section plane? It is an imaginary plane, so which is used to cut the object, so wherein we will get to know the interior. Totally 6 types of sectional views. First one is full section views, second one is half sections, third one is offset sections, fourth one is broke-out sections, fifth one is revolving sections, and finally the sixth one is removed sections. Okay, there are totally 6 types of sectional views for there. So each one of it we are going to discuss one by one with respect to the diagram and how the section is cutted and why each of these sections were cutted in a different manner. Solid is done. In order to get to know the internal details, okay, why sometimes what happens, the internal weaves, internal sketches are not going to give the proper details of that. So for that we use, you can see in the top diagrams, okay, there is a solid which is having 2 holes. We cannot able to find it out exactly in the normal multi-view drawing. So using some imaginary plane we are going to cut it, okay, both in horizontal and vertical plane. So we are going to cut it. So by cutting it, you can see in the sectional view drawing, we can able to clearly understand there are 2 intricate holes were there. One is located with respect to the bottom face and another located with respect to the side face. So that is clearly visible in the section view drawing. Okay, so that's why we do the sectioning. Sectioning will give the detailed drawing about the intricate parts or the intricate diagrams. Okay, So that multi-view drawing will not give the details about it. So we cannot able to clearly understand it. So in order to avoid the confusion, so we are going to do this sectioning of the solid. Broken out section or broken sectional weaves. A broken out section weave cuts away a portion of an assembly in a drawing to weave the expose of an inside. So it gives the drawing weave to expose the inside. You can see in the diagram clearly it has been cutted or broken out to see sectional weave. The section line areas are those portions that have been in contact with the cutting plane. The exposed cut surface is then indicated by section line. So you can clearly see in it. So it is fully cutted with respect to the entire part. So why it is done means, so hidden features behind the cutting plane, sometimes it is omitted unless it is required for dimensioning or for defining of an part, it will be shown. So in fully sectional weave, the entire part of the solid will be cutted in order to show the exact weave. Normally it will be replaced with the full sectional weave because we want to know exactly what will be the hidden features. So all the things can be clearly seen in the fully sectional weave. A half sectional weave is a weave of an object showing only one half of the weave in section. So here symmetrical parts can be shown in half sections. The weave obtained after removing the front quarter, that is 1/4 portion of an object by means of two cutting planes at right angle to each other, is called half sectional weave. So you can see clearly from the diagram there are two cutting planes which are right angle to each other are cutting the solid in a half sectional weave. Offset sectional weave. An offset sectional weave is generated by offsetting, that is bending the cutting plane to show features that are not in a straight line. So this is what we call offset sectional weave of a solid. It is similar to your revolved sectional weave. The only difference is that here the weave which has been revolved 90 degree and it has been placed at certain distance. It has been located at a certain difference. That's what the difference between revolved and removed section. Removed and revolved section both are same. Only the difference is that here the sectional weave will be shown at a certain distance. That is, it is shown separately at a certain distance. That's what we call as removed section. You can see in the revolved section, so there is a cutting plane is cutting exactly perpendicular to the feature in the material which has been cutted, okay, and it will be rotated at exactly 90 degree and it will be projected as adjacent weave. You can see clearly in the diagram. So there is a revolved section has been cutted and it has been revolved at exactly 90 degree and it has been shown as a adjacent weave. So you can see in the below diagram the same thing.